The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning
The
of
James
the
Webb
universe.
Space Telescope is on the verge of unveiling unprecedented secrets about Pluto that will leave you astounded. This isn't just a minor cosmic discovery, it's a game changer that will challenge everything we thought we knew. Our journey begins with the distant dwarf planet Pluto, once hailed as the 9th planet in our solar system. Named after the Roman god of the underworld, Pluto lost its planetary status in 2006, a pivotal moment in our cosmic understanding. According to current scientific theories, our solar system is not just about a handful of planets, but is teeming with countless asteroids, a select few dwarf planets, and just 8 recognized planets. As we venture further, we reflect on the remarkable expansion of our cosmic knowledge over the centuries. We've unraveled the inner workings of celestial bodies, discerned their elemental compositions, and contemplated their potential as future havens for humanity. But there's a twist in this tale. The James Webb Space Telescope is set to unveil mysteries hidden within the very heart of our Milky Way. What will the James Webb Space Telescope reveal about Pluto? Could it harbor life, either known or unknown? Is there a concealed interior ocean beneath its icy facade? Join us on this extraordinary cosmic journey, brought to you by Universal Narratives, where the universe has much more in store than we ever imagined. Pluto, once the 9th planet in our solar system, enjoyed a prominent place in astronomical history for 76 years. However, beneath its charismatic celestial charm, Pluto harbored a secret that eluded the scientific community for decades. It was home to the smallest moon within the solar system. Despite its irregular orbit and slightly oblong shape, Pluto was a darling oddity, a celestial underdog that held an endearing place in the hearts of both children and adults. But this cherished status was destined to face a reckoning as the evolving landscape of astronomical knowledge unfolded. In the dynamic realm of astronomy, change is the only constant. Pluto's fate, therefore, was not an isolated instance, but rather a part of the relentless churn of scientific progress. Public sentiment was deeply attached to Pluto, and when the momentous decision was made to reclassify it as a minor planet some 15 years ago, it gave rise to a public outcry. The International Astronomical Union, IAU, had undertaken a significant revision of the definition of a planet. Under the new criteria, a celestial body needed to meet 3 key requirements to attain planetary status: orbiting the Sun, possessing sufficient mass for gravity to shape it into a roughly spherical form, and clearing its orbital neighborhood of any debris. Pluto succeeded in satisfying the first 2 criteria, but fell short in the third, eventually leading to its demotion to a dwarf planet. The term planet is not a fixed entity, but has been subject to various interpretations throughout the course of history. In the 1600s, for instance, the term was expansively applied, and any substantial object seen to be in orbit around the Sun was promptly christened as a planet. This classification even extended to moons orbiting other planets, broadening the boundaries of the planetary family. With the emergence of the asteroid belt between Mars and Jupiter in the 1800s, a new group of celestial bodies emerged, distinct from conventional planets. Much like the journey of Pluto, which followed a similar trajectory, these objects were initially perceived as planets, only to be eventually reclassified as minor planets. These historical shifts in nomenclature underscore the evolving nature of the term planet and the persistent challenges it presents to scientific classification. However, it was not merely the story of Pluto and Ceres that highlighted the contentious nature of planetary definitions. The history of the term planet further extends to its application to moons. Until the 1920s, moons were routinely referred to as planets or secondary planets by scientists. This convention was not restricted to scientific circles and even pervaded popular culture, primarily driven by astrological almanacs. The term's resilience in non-scientific media played a pivotal role in perpetuating the notion of moons as planets, despite scientific evidence suggesting otherwise. In the 1960s, as humanity's exploration of space expanded, spacecraft provided the first direct observations of minor planets, marking a significant turning point in our understanding of the solar system. These observations revealed distinctions between minor planets and the larger, more familiar spherical planets, necessitating a more precise definition of the term planet. It was at this juncture that the IAU stepped in to offer a novel definition of a planet, sparking debate and discussion within the scientific community. The IAU's definition of a planet aimed to strike a balance between recognizing the diversity of celestial objects in the solar system and preventing the classification of an excessive number of planets. This choice was driven by the consideration of the complexity of teaching and comprehending a solar system with hundreds or even thousands of planets. However, as we traverse the dynamic landscape of astronomy, questions emerge concerning whether focusing solely on 8 planets in our solar system could inadvertently discourage people from delving deeper into the cosmos. The definition of a planet remains subject to interpretation, underscoring the inherent subjectivity in our classification systems. The journey of Pluto took a fresh twist when NASA's New Horizons probe embarked on its historic flyby of the dwarf planet in 2015. This mission unveiled a Pluto that defied preconceived notions. Nitrogen cliffs reminiscent of Norway's rugged shoreline, methane ice shards reaching heights akin to city skyscrapers, and a massive heart-shaped feature captured the collective imagination. New Horizons scrutiny revealed a Pluto deeply scarred by fissures, some more profound than the Grand Canyon and frozen volcanoes towering higher than the Himalayas. This unprecedented visual feast left scientists and the public awe-inspired, affirming the dynamic nature of Pluto. New Horizons close-ups of Pluto's near side provided a treasure trove of data, with details down to a mile of Pluto's surface, a resolution approximately 250 times higher than what the Hubble Space Telescope, orbiting our Earth, could achieve. As the scientific community eagerly delved into this newfound wealth of information, the far side of Pluto remained ensconced in darkness, beckoning for exploration. The far side of Pluto, for scientists, represented an enigmatic frontier, just as enticing as the near side. The initial images, despite their lower resolution, unveiled a Pluto that retained the attributes of a planetary world. A heart-shaped feature, boldly etched north of the equator, corroborated Pluto's dynamic character. An expansive frozen basin named Sputnik Planitia, adorned with colossal glaciers, garnered attention for its profound influence on Pluto's dynamics. The imagery presented its unique set of challenges, primarily driven by lower resolution. However, these snapshots extended a fascinating glimpse into the intriguing aspects of Pluto's topography. Among the fascinating discoveries were the unusual fractures gracing Pluto's far side. These geological features bolstered the notion of a subsurface ocean beneath Pluto's icy crust. Scientists speculated about the history of this ocean, musing over the possibility of a cold start, where the ocean initially froze during Pluto's formation. Over time, the heat generated by the planet's rocky core would have worked to thaw the icy depths, causing surface wrinkling and cracking, akin to an apple's skin after an extended stay in the refrigerator. Pluto's rift, a lengthy fissure meandering from the North Pole to the South Pole, appeared as evidence of the ocean's cooling and freezing. In many ways, it mirrored Earth's East African rift system, though the underlying processes were fundamentally different. Earth's rifts were shaped by the movement of continents, whereas Pluto's rift likely resulted from the freezing and expanding ocean. This newfound understanding of Pluto's geological features shed light on the possibility of subsurface oceans and the role they could play in the planet's overall dynamics. One of the most intriguing aspects of Pluto's far side was its complex, fractured terrain, known as chaotic terrain. This patchwork of hills, fissures, and plains hinted at seismic activity resulting from the collision of subterranean waves. These waves, originating from the rumblings of Pluto's interior, eventually converged on the far side, creating cracks and fissures, mirroring what we observe on Pluto's moon, Charon. This dynamic feature captured the imagination of planetary scientists, and Pluto's chaotic terrain became a subject of profound inquiry. The expansive measurements and images from Pluto's far side further supported the hypothesis of a subsurface ocean, and provided valuable insights into the planet's formation and history. Over time, scientists had speculated that Pluto's ocean had a cold start, with the ocean frozen when the dwarf planet initially formed. However, as the radioactive decay in Pluto's rocky core produced heat, this ocean would have eventually thawed. The ice above would have contracted as it melted, resulting in surface wrinkling and cracking, much like the skin of an apple in a fridge. The intriguing aspect of Pluto's ocean was its potential to support life. The crimson coloration of the water, likely due to organic molecules, raised the possibility of life-sustaining conditions. Complex organic matter with a reddish-brown hue, analogous to substances produced in terrestrial laboratories under the influence of radiation, suggested that similar processes might occur on Pluto, further kindling the possibility of life in this distant realm. Beyond the mysteries of Pluto's far side, the planet's surface featured another baffling phenomenon: the presence of ice chunks resembling towering skyscrapers rising in the easternmost region of the near side. These ice structures defied preconceived notions and were discovered only recently, becoming a subject of great intrigue. They reached staggering heights, dwarfing Earth's largest buildings by a significant margin. These ice formations, known as blades, presented a significant puzzle for scientists. The blades were uniformly distributed around Pluto's equator and appeared to be made of methane ice. However, their origins remained shrouded in mystery. Various theories were proposed, including the idea that these blades might have resulted from methane in Pluto's atmosphere solidifying and falling to the surface. Another theory suggested they might be the remnants of a once comprehensive coating of methane ice, gradually eroded by the intense sunlight. The precise mechanisms behind the formation of these blades continue to puzzle scientists. Pluto's captivating journey and the mysteries it unveils exemplify humanity's unrelenting quest for knowledge, as well as the ever-evolving nature of our understanding of the cosmos. In this uncharted territory of Pluto, scientists continue to refine climate models, striving to better replicate observed phenomena. Researchers are even exploring the possibility of recreating Pluto's atmospheric and oceanic conditions in laboratory settings. Additionally, the James Webb Space Telescope, with its advanced capabilities, promises to offer a fresh perspective on Pluto, unveiling new secrets and potentially unexpected discoveries. As we navigate the cosmic tapestry and push the boundaries of our knowledge, the story of Pluto reminds us that the universe is a realm of perpetual evolution and transformation, where mysteries abound and answers remain elusive. In the end, we are left with profound questions that transcend the confines of planetary definitions, such as the age-old pondering: are we alone in the vast expanse of the cosmos?